I'm dropping frames. I'm dropping frames like crazy. But my settings appear to be optimized for Twitch. So I wonder what that's about. Well, for one thing, I can do that. Yeah, I don't know. My broadcast situation seems to be not so great, but it's kind of working. Man, I'm dropping a ton of frames all of a sudden. Weather's fine. What else could be getting me? What am I not thinking of? Huh. Oh well, I'll just carry on and hopefully the quality isn't so terrible that it's unusable. I can... Okay. Okay. You want me to wait it out? Wait a little bit for it to improve, maybe? Was it getting choppy when I went out? I'm still seeing some pretty bad stuff on that bar at the bottom. It's not, it's... Let's see what's going on. What is this? It doesn't say I'm poorly optimized for Twitch. That didn't help anything. Ooh. Maybe it's getting better. I'm not sure. Canuckles asks if it's internet, Twitch, or OBS going on. I'm not sure which it is. But I appear to be back into green. Look around on my Twitch dashboard. Where would it say something useful? Stream configuration quality acceptable. Yeah, it used to be excellent. What changed? I don't know. Whoops. Alright. Okay, let's I'm hearing that it's doing okay. Alright, we're good. We're good. Everything looks good from my end, so that's good. That's good. Okay, so I don't remember where I left off. Was I about to get into the color palette system? Did I mention? Okay, I remember I was trying to explain this, and it's a little. The game has turns, and I was basically playing one tone of the song at each turn was the idea, and ultimately neither this nor this were included in the game at all. But I left the code in. I didn't even uninclude it because I was afraid of what it would break if I took it out, and I didn't want to deal with taking things out. Right? All I did was I went through and found all the places where I said, oh, color this thing, and I right there I cut that off and said don't color it, just color it white. Everywhere where I said play a sound, I just took that out, right? And then the code that managed all that was still there. It's just that I never invoked it. And it shipped in the game. And the reason for that is I didn't think I could take it out without breaking stuff. And because there were so many different little places all scattered over the place, and because I was using Visual Studio or Notepad as my editors, I didn't have a good way of getting to those. Even if I did a Visual Studio build, it would give me errors and I could skip to them, but I was still worried that there would be some dependency that some other thing had built in or something, and it wouldn't work. It wouldn't work out, and I had no easy way of making sure that that wasn't going to be true because my code is just too spread out at this point. But let's look at the color palette system, which didn't actually make it into the final game. So the color palette system looks like I've got a color palette is just a map. So I decided at this point maybe, and this is the great thing about this project, is it's not just OOP, it's everything. And at each point, you'll see random experiments of, oh, maybe what I should be doing is this, right? So like I said, by the end I was just throwing functions into a namespace. And I watched Handmade Hero, and when I came back to finish this, I didn't even add new files anymore. I just crammed things into existing files. But before that, I was experimenting, and what this particular thing does is I type def color palette. Later, it turns out that doesn't work, so I throw color palette into a CP. So no win, even from trying to avoid a class. I thought, this is really just this type is really just going to be one of these. No point in wrapping all that in a class. And then I was forced to wrap it in a class because C++ won't let me forward declare this without having this information. And to include this in the game container, I needed something to declare. So I ended up making a struct CP anyway. Again, another good reason why you don't want to have to do tons of forward declaring. I thought this would be really clever when I first did it. Where is it? I thought this would be really good. You don't want to have to do this because it's another place where you have to make sure to add the name of things. And the only reason you're doing this is to avoid including this tons of headers everywhere. So just don't have too many compilation units if you can help it. What is the lesson there? And then get palette is about you put in a name and outputs one of the color palettes that exist. And I think with that there's probably a private, and when I say private I mean like locally existent data. Yeah, there's a lot of data here. It looks like I was just declaring the colors in line, which is interesting. Surprised I didn't decide to load that in from a file in XML. Alright, so that's the color palette system. Anything else here that catches anyone's eyes? Game functions, common variables, main state game, main state start, direct loader, object type, anything anyone wants to see. I can also go see what's going on in the main function itself. Any suggestions? I'll start doing main until I see some suggestions. What do I do here? So I've got game setup details. This is basically looks like setting up a screen. And since I wouldn't want to have to pass those, as parameters to a function, instead I give each one a line and a name. Yeah, I get named parameters for that. And I don't have to call this more than once. So I don't know if this is a terrible situation. Probably better. The reason this had to happen, though, this is not ideal, and a lot of things force this upon you. Like you even have to do this sort of stuff to set up a window in WinAPI. So this is, what can you do about that? that might not be a terrible choice sometimes. But it was actually definitely the result of me trying to initialize game container, which needed all kinds of information that could have been split out into separate functions. That would have made it easier if each of these was a separate function call. That is probably how I would have preferred it. But because it all has to go right here in one big, gigantic class, that's how it ended up. Okay, so here's an interesting thing that happened in the game. At one point, there's this whole grid system. So let's take a quick look at the grid system. Okay, go to grid, and go to, there we go. Oh, you want to know why there is exception handling? So I think there is a little bit of, yeah. The resource system, we didn't get all the way to the bottom of it, but apparently at the very bottom, we can have some throws. Yeah. So this does the throwing. And that was the first thing I implemented, actually. The first big system was the resource handler. And that's the only time I used exceptions. Nothing else in the program uses exceptions because this turned out, it didn't help me catch errors. So it failed at its primary function. It made my life worse. And on the error handling front, it was harder to debug errors. And it ruins all of the code that it's in now because I have to try catch everything. So I decided that right there I learned I was never going to do this again because I decided that this is just not useful. And again, this was me not trying to be clean. Before this I would have done this all the time and just assumed this was the clean thing. But at this point, this is sort of me trying to find the easiest way to get things done, and I learned this was not the easiest way to get things done. I had not yet learned that rewriting your code when it's bad is a good thing to do. So this stayed in the game. But that's something you also want to learn. If you realize that something is bad, you want to redo it. That's a good lesson to learn from this. But anyways, that's what it's doing tries. And what's happening here is I implemented the two different instances of grid wrap. And grid wrap defines how you want to wrap, given a certain position and a width height, how that wraps. So if you have a rectangle and something goes off the rectangle, should it wrap into the rectangle this way, or should it be more like a Klein bottle, which is what this one does, right? This is a torus typology, where this is a Klein bottle typology, and which means basically it's like a Mobius strip kind of thing. The thing is with this, I mean, it would have been easier. This didn't really have any bugs because I ended up not even using this, and again, the code just stays there because it's hard to find. Like if I'm going through main and I go, oh yeah, that does grid torus, and if I go check that out, they happen to be right next to each other, thankfully. If they had been in two separate files, I never would have known that I had this unused grid Klein, but I wasn't even thinking about taking old code out, as I explained, so. But that would have just been easier to handle with a switch, that particular one. So that didn't need polymorphism because it spread the code out in a way that it shouldn't have. Here's the tone builder. Like I said, I didn't ever take any of this out. Just not going to get used. Here's a tone bank. Here's the normal player. So there's an idea at some point that there would be other types of players. So this gets a little interesting. Normal player. Multiple inherits from a moving object and controllable interface. Controllable interface is anything that's going to take key input, you know, mouse and stuff, or not mouse. What am I saying? Key input. The arrows. That's the word I'm looking for. It's going to take arrows, and it's also a moving object. So if we go look at moving object, we inherit virtually from object base. We also inherit from facing object. Facing object, by the way, it's just some data. It's just about which direction you're facing. Almost certainly would have been easier. The reason I inherit from this is because what I really wanted was a public member. But I thought, oh, I want this public member in so many places, and I'm still doing getters and setters. It'll be easier if I just make it a class. That way I can inherit everywhere and have the getters and setters in one place. So that's me trying to use old-fashioned member function inheritance to make my life easier. It would have been much, much easier to just make a public variable everywhere that I went, but that wasn't going to happen because I had not yet realized that that would be okay. And again, I wasn't even trying to be clean with any of this. I just didn't believe it was going to be okay if I did that. It's different. I didn't. In my head, I thought it was a serious problem if I made a public member variable. Even though I wasn't trying to be clean, there were certain things that I just accepted as important that were absurd. So anyway, that happened, and let's see what else was happening with normal player. I wasn't done with that one. Controllable interface, yeah, moving object. Oh, by the way, every object has a builder inside of it, and the builder inherits from unit, and it's a factory for creating instances of this object. And they have to be inside this because I use some template meta tricks to pull these things out. So that's happening too. I'm using a template to find the builder, which is a polymorphic object type, and I then construct one of those if I want to make a loader for creating these objects. That's happening in this code. Let's go to moving object. What's happening here? Oh yes, the virtual object base. So virtual inheritance, by the way, is how you know inheritance got screwed up, because there's two different concepts of inheritance that don't go well together, and what I'm trying to do with that particular one is that the object base that I'm virtually inheriting, it wants to be the same object base, even if I have, all these other multiple inheritance things going on that are totally crazy, and all of that's just the wrong way to structure what I really wanted, which was an easy way of composing objects, of laying out data, but I wasn't thinking in those terms. Okay, so I was thinking in terms of objects, but if I had known I was just laying out data, it would become a little easier. Let's see, so here you can see I did a little bit of data stuff, and really this is, if you take this out, this type name thing, this is for identifying, once you've got a pointer to an object base, you might want to know what type it is. Crazy enough, sometimes you have the base pointer and you actually want to know, you care what it is for reasons you don't feel like cramming into another virtual function. So instead of cramming into a virtual function, you'd like to get some sort of ID. I chose strings for some reason. And that was actually a performance problem at one point, because I had a long chain of if, else, if, that I was comparing strings all the way through, and I think what I ended up doing was I had a way of going to an integer ID thing temporarily, because I didn't feel like changing. Again, I didn't feel like making the whole system reasonable. I just felt like making this one thing work because I was in a mindset where if you change something, everything's going to break, and it's all been built on that one thing. All of these concepts have to change, and you've modeled your code after those concepts so strictly with your objects that it's going to be hard to change this. So it's kind of locked in. But let's see what else happens here. Not too much stuff. For some reason, I also thought it was important that I formalize the concept that something exists on a grid. So this position here is separated out. And then the concept of an instance, which you wouldn't think is important, but it is, because I needed an instance manager, obviously. Because the instance manager's job is, by the way, it's apparently got a internal class called remove callback. I don't remember what that does, but here you can see that because I have this private instances set that I want to iterate over sometimes, I have to have these functions that take a callback so that I can iterate over it and pass the callback in. Would have made it much easier if I just had access to the instance, but what can you do? What can you do? I didn't have access to this because I thought something would be bad about putting variables here. I don't know why I thought that. It's just something I believed was true. I believed the simplest possible thing involved private members. So even I knew public variables existed. It's just I thought things would go wrong. Like, I can't even explain it. As if random people could just swoop in and change your stuff if it was public or something. Which is kind of what they say. Someone might change this thing. It sounds like another program on my computer will change it or something. And I wasn't sure. And since I'd always seen it done this way, I didn't want to test that. I was just trying to get something done. And the simplest way I knew how to make things work was to put it private. So and I had, I had given up being experimental. So this went into the private section, and then I looped across it, and I have this generic callback that I pass to, etc. Right, so that instance manager is basically that's just my list of instances and some data for describing them, but I didn't know that that's what I didn't think about it in terms of data describing instances. I thought about it in terms of this thing, there's a bunch of instances floating around and this knows where they are. Alright, so that is a little look into how the player and objects work. Oh, and one other interesting thing, the player, it turned out there was a problem. So the player is the only object that gets created once at the beginning of the program, and instead of being created when when a level is loaded, it's the same object every time, and it gets moved there. And the reason for that was some like weird scoping thing or something. Like the lifetime of the object mattered, and I don't know if it mattered when the game shipped, but it mattered at some point, and I had to keep the same player open forever. So this gets created at the beginning. Everything else gets loaded through crazy builder factories. Well, I've been going for about an hour. I don't know how long people could take this. I mean, there's plenty we haven't seen. I don't know if you've got your fill, if I've made it perfectly clear how far I came when Handmade Hero started. And if I've offered anyone who out there might be questioning why there's things wrong with this stuff. I'm sure I've done a terrible enough job that that doesn't even count. You'd have to do better object-oriented programming than this as your counterexample. But does the crowd want more? I'm not seeing any chatter in the chat. Oh, there it is. Alright, let's see if I can dig up anything else. There's plenty of goodies and maybe some nuggets of wisdom to find in here. So here's more of stuff that I didn't cut but that should have been cut. Object type list. Set type traits. Ooh, what is all this? Why am I getting an object type list? Here's another great thing, since I went with all that pimple stuff and I'm returning references, you have these great things where you call a function to get access to an object. So once this returns, you take it and call another function. And I decided way before Handmade Hero even started that this was a mistake, but I didn't feel like fixing it. So, let's see. This. What is this? Object type list. I'm curious. What is an object type list? I forget. Okay. So at some point I decided that instead of having an array of builders, it would be easier to do this. So that changed. I'm at least willing to list members. Sometimes you use your code as data, and that's what this is kind of doing, but it's still, each of these is a instance of a polymorphic object, so what can you do? Like I said, this is that builder. Actually, this might have been me getting out of using a template for this, because at one point what I would do is I would take this, I'd take this object here, and I pull a type out of it, and I was doing this through a template. So what I would actually do is I would say, given this type, given this type that I don't know what type it is, do : builder to get its builder type and construct one. And at some point I might have decided that that was a bad idea and stopped doing it. Maybe that's what this is evidence of, but we have to check and see. We have to check and see. Load units, is that a define? Yes. Oh, look at this. I defined a struct. Okay, so this is an anonymous struct type. So I was getting into the idea at some point that I could define data in my code, and that sometimes what I wanted because what I was doing before was I had down here and up here two different things, both of which did basically totally different things to the same list of objects, like object pairs or same data list, and I thought it'd be great if I pulled this out. And this is true. It would have been easier than I made it. I didn't have to, like, for some reason I decided that it had to be a local, well, here's what's going on. It had to be local because these are data members, remember, and even though there's only one instance of this class, these are data members. And since they're data members, you can't define this globally. It just won't work. Now, maybe I could have done member pointers, which are also a disaster. But luckily, I was over member pointers before this project started. But I did spend a long time loving them, or playing with them, or doing, I don't know what you'd call it. But I didn't use member pointers because they're insane. So, and they'd be great, be super useful if they were correct, if they were done right. But they're so hard to use. So anyway, it's a macro that defines locally all this data, and then you loop over that array, and at each point you do something. And what you do is different whether you're adding a trait or adding a unit. And I'm not totally sure what a type trait is. I think the idea was with type traits was that you would say, like, oh, is this thing a floor type or not? Is it, is it susceptible to getting killed by a bullet or not? Is it pushable or not? Stuff like this. So that was type traits, and up down here, it's just setting things up. So, so what a loader does, I remember where the templates are. I'll go find the templates. We'll go look at the templates in a minute. What a loader does is, the full loader is for loading levels. And the idea with the loader is you input some, like I think it was 4 bytes of data. And those 4 bytes contain an ID of what type you are and some information that encodes the state of that object, whether it faces up, down, left, or right, and other things like if it's a wire, is it on or off, or intermediate, etc. So this loader would read in 4 bytes at a time and create objects in the game. And the way it would figure out which object to create, though, is I didn't have a switch. Even though I was bringing in 2 bytes that would encode which object I wanted to create, and I could easily switch on those 2 objects. Instead, what I did was I treated each of those as an ID, and I said, pair that ID up to one of these loader objects, and so I don't have a switch, I have polymorphic object. Guess what? It would have been much easier as a switch. That's just straight up true, because I could take the two bytes and switch on it, and that would be it. The only thing I win for having the loader objects is, if I look at one of these, the whole point, if you really wanted to do it with this one advantage, you couldn't get this with a straight up switch. You could get it with other more sane things. I have to go to a game object. Objects. To take a look at, where's normal player again? So what do I get for doing it through a polymorphic object? The only thing I get is that I get to pair it up with the player, right? I get to put it next to the player. But the only reason putting this next to a player is a problem is because everything is spread out in the first place. Nothing would have been spread out at all if there hadn't been so many object types in the game. If there had just been one entity type that was used to encode all of the types of objects in the game, there would have been no spreading out. But that's not how I was thinking. I was thinking the simplest possible thing is you make a type for the thing you want in the game. And I wasn't sure if that was the right call, but I didn't know what else to do. I wasn't thinking in terms of computer and data. I was thinking in terms of what code do I write to make this happen, and I was just using the things that I had seen being done. Vealbus asks, I don't know how to pronounce it, I think that we've been over this before, but asks, what type of game is it? And it's one of those Sokoban type games where you have a player and you push blocks, and in this particular case you try to get to the end of a level flag, and not much else to it. I mean, most of the game is about sort of playing through and figuring out these cool rules of how space and time work when you're in a grid, and when everything is discrete. And that was the idea, and by the time I released the game, Sokoban had gone through this huge explosion, and everyone was making Sokoban games. So maybe they were popular even before that, but. Alright, so anyways, the whole point of doing it through not a switch but a polymorphic object was that I didn't want to separate this from the player stuff that shouldn't have been separable in the first place, but there shouldn't have been so many files, and this wouldn't have been a problem. But since the files were separated, I decided that this was the right choice, was to put a polymorphic object here and call into it. Probably still not the right choice because all of these are so similar. In fact, most of them use templates. So, how do I make the builder for this object? I type def it with this template, and I tell it what type it wants to be. This was why I was using this model where they're all inside of a type, was so that, you know, I could type def with this thing here, right? And the reason there's a template for this is because there's so many things that do the exact same thing when they load. So guess what? The switch would have been easier still because it would have put all that similar code together, and I could just put their cases together. But instead, I opted for template. So definitely the wrong choice in hindsight. Of course, I wrote this code before I knew how I was going to encode objects in a file. So that's another reason why I wrote one thing, and then I thought to myself, wait, I have to encode this in a file. The pointers to the builders isn't going to be useful at all, and now it looks very silly. Before I had any way of anything to actually load, it was the only thing that, you know, the promise is you write this and it'll work no matter how you need to use it. But really the truth is more like it won't work no matter how you need to use it. Anyway. This is the common extended version of the unit builder, right, which inherits from unit. It's a template. It takes in the type you want to build, and it says, okay, we want to do this. The extension is that it calls the setup function. So it does the new, and there's a setup function in T. So let's go look at what the setup function does. Is there a static setup function here? Yeah, static setup function. So why I didn't just do my own instance of the object at that point, I don't know. Like, why I didn't just make my own builder, I don't know, but I decided I needed a template that said to find this function and call it. I don't know. If I find one that didn't use that, here's one that's using the common unit, which is not involving that extra layer of template madness. I go to that one, and you see it just creates the object. Through its constructor still, generically, but it just creates the object. So that is how things got loaded, somewhat. Anyway, that's some information about how things got loaded. If we were to look more at the loader directly, the loader basically has, once you've added all the loading units, so each unit is capable of loading one type of object, and there's a map of them that maps not strings but shorts to them, because like I said, at one point I realized the strings wasn't going to cut it for loading a level. It was too slow, so I switched to ints, which made it good enough, but like it's in a map and it's still going to suck. So it is certainly a not good thing, but because the game was so simple and because I wasn't willing to push the game to be better, partly because I knew how hard it was going to be to make my code actually do it. Again, well, that's another thing. People sometimes, I always wanted to say this, so I'm just going to get it in there. Game designers don't always realize how much the tools they're using actually influence the game they make. And I say that because my game got watered down a lot because I was using all this and I couldn't figure out how to make it good. So I just gave up and went with what I was able to get done easily. It would have been, I just couldn't handle the idea of going farther than where I was. And it's also true of engines. And I say that because if you can think to yourself, when you play a GameMaker game, or you play an Unreal game, or you play a Unity game, if you can recognize the engine that made it, then that engine influenced the design of that game and the outcome of how that game went immensely. Right? If you can identify which engine out of it, it's not even just, oh, this is an engine game, but you know which engine it came from, then that influenced the designer a lot. And I think for games to do really, really well as a medium, you want your designers to have the freedom to do unadulterated design, not design forced on them by, not have their designs guided by the engine they're using. And I think that happens way more than they realize. Little philosophical game point. Anyways, that happened to me in this game, but not with an engine, with my own handmade, but terribly handmade, because I wasn't thinking about the computer code. And, anyway. So let's look at what spawn object does real quick so we can get back. So what a loader basically is it's supposed to, the point of it is to provide this function where you get to say what kind of object you want to make, where do you want to make it, and where's the game container that needs to get loaded into, which is a somewhat reasonable function for having, I think. I mean, it's not the craziest thing. You might actually have maybe it doesn't need to be a function because it only happens once in your code, which might be true, but once you're separating things into classes, whether something happens once in your code sort of becomes irrelevant. It's hard to make your code not become all fractured into a bunch of tiny things over time, which isn't helpful, but anyway. All this thing really does is it finds the object type, and then it finds the builder. Yeah, it finds the builder for your object type, and if it was able to find it, it builds the object. Alright, so that's the direct loader. We're now 15 minutes into the second hour. Has everyone still got stamina? I didn't expect it to go on past the first hour, so I'm asking, I'm going to make sure that you're still with me. Because I think there's still more. There's a launch function. We might need to find out what that does. Seems important, because so far all we've done is instantiate stuff. Somewhere something has to happen, so maybe we need to look at this. Maybe we can talk about what this is. Why it's called Builder. Why I liked Builder so much, which was my way of naming factories. Because I was embarrassed about the fact they were factories, because I had already sort of thought that factories didn't make sense, but I was using them. And I thought, no, but it's different. Because I got to this not by following patterns, but by just doing the simplest possible thing. Alright, Kalimian wants to see this factory. Alright. Alright, let's take a look at what this is doing. So, oh wait, it's autoed, so I can't find out. Okay, the type is right here. Good, good, good. So main state start builder. What's the point of this? Well, the point is there's this little problem where I was already under the impression that my game needed states, right? So at the beginning of the game there's a splash screen, so there's a state for that, and then there's, after the state screen, there's either you go to the main world map, or if it's the first time you played, you see the intro pages to the little book in the game, right? So you see the intro pages or the book depending on whether you have a save file, and each of those is a state, and then there's mini maps for each world. Each of those is a state, and then there's a state type that contains. Well, there's one state type for all world map for the world map, one state type for each mini map, and there's one state type for actually playing the game, and then there's the state type for reading a book. I believe that's all the state types that exist. So I abstracted that concept into the main state base class, and this was a little bit more rote object-oriented programming at this point. It's not all the craziness you see everywhere is going on here, but some of it. We still have the game container pointer, involved, so you're not going to get too far away from it. And so we can I'm making sure to label a few of these const because they are, which is really, really great with virtual functions when you label them const. It's you don't know for sure that it's always going to be right, but you give it a shot anyway. So anyway, what is going on here? This base class knows how to execute one frame and draw. I separate those out. Not really any reason for that, because I usually just call execute and then I call draw, but it is what it is. And then there's kill me, which is whether or not this particular state is ready to, like, if it has queued up the next state. So there's a system, the main system, when we see how it gets launched, that's managing this, and this tells that system to kill this object. There's resume and pause, which are, they tell a state that it should pause execution and that we're going to come back to that state and resume. And then down here, there's the state builder. And the state builder is there so that when you need to create a state, sometimes you don't want to create the state yet, and you'll see why later. And so instead you make a state builder, and you say when you are ready to create the state, use this builder to make the state. And that's got to be virtual because it's got to be able to make every type of state. So a little bit about this. This doesn't need to happen because even if you're going to do this, you could just have first of all, you could just architect it so that you can create the state when you need to. But short of that, you could just encode it in a message as an ID and switch on it, of course, and have that switch return which of these things you want. Now, if you're already doing this, maybe that's not a big win. But then the other thing is, this turns out to be a big pain in the butt because some states want to do this pause thing. And really what I didn't want any of this. What I really needed for state was one state variable that said what state am I in, and a bunch of variables that can contain information about, it contains information about what it is you want to, like, you have the one state variable about where you are now in the game, and the other variables that are global contain what's actually happening. What level are you on, or what minimap are you on, or whatever it is. They don't need to be encapsulated into these classes. It didn't really need to happen. But that's the way it is. And then, what is this? Oh yes, so sometimes I thought this was clever, and then there's a little glitch, so there's a little flaw in the logic, which is that if I'm going to pause something, and then I need to enqueue the fact that I want it to be resumed, that isn't really encoded in all this, so I need a builder that doesn't actually build things. This isn't even a factory. It doesn't factor anything. It doesn't make anything. All it does is reuse an existing one. So you tell it which one it's going to reuse. It keeps the pointer to the one it's going to reuse, and when you ask it to build something instead of building it, it returns the pointer to the one that it was holding on to. So that's, again, you come up with an idea on how you're going to abstract something. Turns out it's not going to work, and you got to hack it a little bit. Happens all the time. So you don't want to start with how are you going to abstract this. Not the way to do it. Okay. But let's take a look at an instance of main state. All these states are stored in here. So any one of these is one of those. So, for example, level select. What is that all about? Let's take a look. So it's got its own builder. Loved a good builder. And it's got an underlying, so, who knows what that's about? Well, that is because when you build one of these, it needs to know who its underlying state is. So I guess when you're level selecting, you maintain a pointer back to the world map, probably. The world map state needs to stay alive forever, which is just a good hint that maybe these variables don't need to be in an object, because the point of the object is that the variables have a limited lifespan, and the map ended up staying alive forever. So why were they in a class, right? It should have just been global variables somehow. Maybe in a struct or in a class that was globally accessible or easily accessible, but not hidden behind the private portion of a state that is a base class of a polymorphic thing. That's too much for something that's, you just need these variables to always exist. This memory needs to stay in the game forever. That's all that really needed to happen. So it's, and when you want to do simple things like keep this alive forever, object-oriented programming is going to make it a little hard on you, because it's all about getting rid of making things harder to access for some reason and putting a lifespan on them. So let's take a look at maybe one of these. Well, this is not going to get us anywhere. We need to look at the launch function. That's what? Do I not have the launch function in the code I brought? This is the workhorse function. It does the game loop, which you always want to put your game loop somewhere away from your main so that you can't find it. Wherever your biggest intro function is, the one that describes everything, don't put your loop there. Loops don't look good in main. It's better to launch your program with a launch function. Game functions? There it is, launch. I want to peek the definition. Thank you very much. I want to go to the definition. There we go. There's launch. So here's the game loop. It's a good thing it's in this function. It's called once so that it's harder to find when you're looking for the game loop. And what does it do? It says while the window is open. The point of me saying that is you don't need functions that you call once just because you'd like to name a process, right? A function isn't there so you can name things. It's there so you can use it more than once because it's useful somehow. It can encode some idea that you'd like to not duplicate your code, so this should have just been inlined. It would have been easier to find the loop. But here we are. While the window is still open, it gets a state change. It says, is there a state change? And it says, if there is, that's a new state builder. If that state builder is non-zero, right? If there's actually a state builder that exists right now, then we want to do is get the current main state and see if it exists, right? If it does, ask if it wants to be killed, because it doesn't necessarily want to be killed. It might want to live forever. And at some point, I probably didn't have the kill me function, and then I realized some of these things need to live forever, so that becomes a little harder. So I said, do you want to get killed? And then I kill you if you do want to get killed. And then we build the new state using the builder, and we delete the builder. We always delete the builder. And the great thing is this just is a sign of extra memory allocations going on too. And happens after that, we set the game's main state to this new thing we just built, and then you reset the fact that we no longer have a state change. So set some variable hidden in this function. It's not a variable set. It's got to be a function call that says set that back to null. But you don't know that that's what it's doing because it's hidden behind this function. So don't hide just because it's a global variable or a variable inside your... So I already knew I didn't like singletons. So this isn't a singleton. I don't use a singleton pattern, but it is the only object of its type in the whole program. And I just made my life harder by passing it around because I thought that avoiding the singleton would be better. I thought, I learned that singletons were bad, and I thought that this was the solution, but this isn't. Singletons are actually a solution to this, which is a problem that you have because you're using so many objects in the first place, right? And this is me encapsulating the fact that I'm setting a pointer, which, oh, by the way, isn't actually that simple because I'm using a variable system. So this right here, if I go look at the generic get function, I'll bet you it's doing variable. It's using variables. Yeah, so here's where I define names for these variables that I'm storing dynamically now, for who knows what reason. Rather than just storing them, I have to store them as strings. I don't even know. I do not even know what this is. I have no idea why it would be necessary to store a few of your global variables as this. I think by the end I knew that this was not a good idea, but I again didn't want to take it out because so much stuff was based on it that it would have been a pain, and I did not believe in rewriting code, which you should always believe in. Okay. What is next? Well, I was looking at game function so I could see that launch function. Then it does execute and draw, one after the other, as I said. So execute and draw, not separate. It's just execute and then draw. It could have been one thing, but it's two things. And then I tell the window to display itself. So that's how the engine, that's how my game engine worked. Any questions about? Are there any details which are still a little bit too clear that you need me to explain? If anything is still clear, I will explain it now, and we will fix that right away. Alright, so I think we've gone through most of it. I mean, there's plenty of stuff we didn't visit, but there's upwards of 100 files here, if you count header and CPP separately, just in the main application. There's also these CSV, my CSV test. The level formatter is a whole pile of wonderful. And the old level formatter versus the new level formatter, where I did more folders so that it's harder to find things, more tests, good test-driven development on my side projects, etc. So I think we've probably visited enough to make my point, which is just Knuckles asks, by any chance, have you ever touched the game programming patterns? What do you mean by that? I think I have. It sounds familiar, but I don't recall if that's a website or a book or something. I remember reading something online about it. I could maybe throw out an opinion before I put in my last little bit. D7 Samurai wants me to do 1K of Hail Marys, and when I say K, I mean the 1024 kind, the 1-bit shift 10 kind, not left shift 10 kind, not the unreasonable metric kind that is actually perfectly reasonable. That's funny. Knuckles, you still there on that game programming patterns thing? If you explain what you're talking about, I will answer that. What I wanted to say at the end of this was that all of this happened because I was just trying to move ahead and get something done, which meant not backtracking and writing code, not researching if there's a better way, just trying to sit down and get something to happen. And that's a mindset that happens a lot, is you want to finish something. And it's not all that different from actually just wanting to hand make everything. And there's some extent, once you say you want to hand make something, that's what's going to happen. So that's what a lot of this is way more handmade than things I made in the past, which involves far many more libraries. I think I got this down to 2 libraries that I was using, SFML and RapidXML. And I was actually proud to be linking to less things, but the point is that I didn't know what I was supposed to be measuring in my head. I didn't have a mindset of experimentation, and I didn't know that I should be measuring things such as performance in terms of memory usage uh, uh, and in terms of speed, but I also didn't know I should be measuring how each thing I did was affecting how productive I was. And if I looked at how much time I wasted on things, I would have realized that I was making a lot of mistakes. But I didn't know I should be measuring any of that. And so an important point is that not only do you have to make your own code, you also have to make sure you know what you want to measure in your code and make sure you know that that's the thing you're optimizing. So if that for you that is your productivity and the performance of the code, you should know that just writing code to get something to happen is almost always going to be not good if you're not optimizing for the things that are going to make that possible. So, and I'm talking about optimizing in terms of like making things reasonable so that you can debug problems quicker and stuff too. So that's my little conclusion from this. Was all this happened because I was trying to make something by hand, but I didn't really have a mindset of experimenting and measuring and improving improving what I had so that I would get better results according to my measurements, right? So that's an important aspect of all of that. And Canukel says, that he's talking about the book and the website. Wonder if the book is good. The author seems sane so far. Maybe he's just an okay writer. I haven't read the book. I remember looking at the website, and I was only on the website because I was trying to figure out schemes other than the one I knew for handling frames of a game. And he seemed to have an actual understanding of how frames work in a game. I didn't look at anything else he did. And I was looking at that, I was impressed by it because he was explaining things that I was thinking to myself, I don't know how I would control that. And if I went back into it now, I could understand what he was saying. But back then, I was still handcuffed by my way of thinking about code and programming. So I didn't even understand some of the things he said. But on at least that one thing, I remember being impressed that he was talking about actual timing intervals and when to do computations and when to show a frame and stuff. I might be building up in my head now. It might not have been that good, but I don't have too much of an opinion. I just remember that one interaction I had with it, and it seemed okay, but I'd have to look at it with fresh eyes. Yeah, the lag does seem pretty bad. I wonder if it has to do with the timeout from earlier and stuff. But anyway, it's been actually somewhat frustrating for me, but I hope everyone else had some fun. I'll be back tomorrow with a normal stream, generating trees and stuff. So thanks for watching. Thanks for coming out to the chat and hanging out. I appreciate it. See you around.